let's.
Um,
Okay.
okay, guys, let's start. So I will introduce Noam. Noam came from our Israeli office, and well, we had not a lot, but we had already talks about TDD and testing. But Noam knows the secret sauce of writing and keeping clean and small tests maintainable. So please welcome Noam.
Hi. Oh, is this working or? Oh, it is? Okay. Thank you for coming. My name is Noam. Like he mentioned, I came from the Israeli office. I've been working at Wix for like more than 3 years. Been writing a lot of code, trying to fix it, trying to make it cleaner, and then I thought it was perfect, and I did it again and again and again. And today I have like enough mileage I can start to talk about it, but there is always room for improvements. This talk is, I know that not all of the people are back-end developers, so if you, and I will present some of the refactoring in Scala code, but most of the ideas can be implemented both in like every language that you use. It's JavaScript or PHP or whatever. Well, maybe not PHP, but so anyway, tests. It's everybody, like if you came here, you probably believe in them. And there is a lot of talking about test-driven development that helps design and red-green refactor, so it allows you to keep your code cleaner and refactor it. And have less regression, but nobody talks about the tests. Nobody cleaned, like, as a developer, sometimes you come, you have to write a test, so you write a test just to make the code, before you write the code, and then you are anxious to go to the code, and when you write the code, you finish, and you look at the test a little bit, and you say, okay, well, it sounds reasonable, now I have another feature, I have another bug, I have another something that I need to do, and you forget about the test. But tests are actually, even though we say test-driven development, we don't consider the test. We always consider the code. But tests are actually more important than the code itself, because if the tests are not maintainable, if the tests are not clean enough, and someone else, or maybe even you, and it happens a lot of time when you access your old code and you go, and who did that? And then you realize it's you. So if we can understand ourselves like a couple of months later on, we have to pay extra careful about how we do that. But first, let's look at some code. This is a test. I looked for some of the frameworks, most used frameworks in GitHub. In the end, I managed to find some of the tests that I could use as a sample. One of them, this is from Guava. This is a simple unit test written in JUnit in Java, and it does a few simple things. Well, first of all, it creates the future that it want to test. Then it, for some reason, asserts it. It calls get. And then it expects an exception. It's fairly simple. Everybody can relate to that. But let's consider guidelines when we write some tests like this. First of all, when it comes to testing, it's all readability. It has to be readable. It's because everybody. There are some people who say that the tests are documentation of your code. I want to say, I want to agree with that, but it depends. It depends how readable they are. But readability is one of the most important things when you write a test like that, because everybody who wants to later on change the code, he will look at the test first, and he will try to understand it and see what you meant when you wrote it. And if, for example, you write something that someone don't understand or don't expect, then he will have trouble to actually fix or change the code that you wrote. Another thing is maintainability. Maintainability is very, very important for the test, because if you have tests, for example, that every time when you change something in your code that doesn't change a lot or doesn't change the behavior, and then you have to go back and change the tests every time, it usually implies that you're doing something not so good. One of the most important tests are, by the way, their trustworthiness. If you can't trust the test, then we didn't do anything. You have to know that, you have to trust the test, that they test your code as you meant and you wanted it to run. If that trust is broken, then the test doesn't mean anything. One of the things that are very very important when you have a test failing, you also want to know why it failed. And this is also, by the way, it relates to the maintainability part. So if something failed, you also need to know why it failed. And what is a clean test? What is clean? Well, everybody can have their own definition, but I think that the first thing that you need to look at a specific test is, can it stand on its own? Can someone actually look at the test that you wrote, read it, and understand from reading it and not going into 50 other files and verify what's in there? He can just look at the test and know, okay, he is testing this and that behavior. Another thing that I can, a guideline to know if your test is clean is if it describes what you're testing and not how you test it. It doesn't describe that it adds 5 plus 5. It describes addition. Another thing, does the test actually express what wants to be, what you want to test? If you have a test that it has a certain amount of lines, and when you look at the test, you go but what is he testing? Is he testing that the future fails with exception, or does he test that the future actually handle a future, or does he test something else? The more data that you have in the lines that you read makes it can give different meaning for the test. And can there be something too clean? For example, this is a code that came from our code base, and at first, when you look at it, it looks clean, it looks nice. Although, when you start to really look at it, it's a little bit hard to understand what is it testing. Does it test the record function? Does it test the log event? In the end, it checks that there is an event with BI with entries. But where does those entries come from? Do they come from the log event or the record? So this test maybe took it just one step forward and hid some of the information that you wanted to see. So even if you clean your tests too much, or if you pack stuff into too many helper functions and drivers and code that sits someplace else, then it's hard for people to read later on and understand why does it work and why doesn't it work. So the first thing that when we start to look at tests, we need to understand the basic structure. The basic structure of a test is very, very simple. I think everybody who wrote the test knows. It inits some of the context, defines some of the variables, some of the construct that it needs to test. There is a test description, and later on, there are 3 different aspects that you are testing. There is the given part, which set up the test environment. There is the when part, which is what you're executing, and there is the then part, where you match the expectation. So givens, it's almost like a mathematical proof or a behavior that you're checking. You're defining something, then you're doing something, and then you expect something to happen. If nothing happens, then there is no reason to test it. And let's look at the first test that we did before. There is the given part. It creates new futures. Then there is the when part, we call future.get, and there is the then part, where we assert that the exception is being thrown. This is the three basic things that we have in almost every test. By the way, if you see a test that have too many asserts, like for example, just a comment about this test, which is okay basically, but this part on the first part of it, there is a few asserts on it, and as someone who reads the test, even if this test looks like organized, it doesn't. Well, what am I testing here? I'm testing the exception, or do I test like the future is being constructed as it should? So this is one comment that you can just automatically see, because there is two assertion parts. Any questions? Feel free to.
Actually, there are 4 tests, I see, no?
4 tests, okay.
Yeah. 4 asserts. Perhaps it should be as a 4 separate piece of tests.
Yeah. By the way, there are language like in Scala, as I'll show you later, you can write a matcher that tests this whole section, because basically this part is not supposed to be called. What happened is like I said, this is the given part. It's all the way here. It creates a future and then it validates stuff on it. But well, I'll not refactor this test. I'll refactor the different tests. But
yeah, but my question is about first part of this test, about 3 assertion.
Yeah.
Is it given part, right?
Yes, it's the given part.
So if something failed in this assertion, in this list of assertion,
the test would fail.
It's a fail inside given part. It's not a failed test, right?
Exactly.
Yeah.
This is why, by the way, one of the points that I wanted to emphasize. It's when you read it later on, you're looking for blocks. You're looking for areas where something should be tested. For example, in here, like you said, it's true. I'm creating this object. Why do I need to assert that it's being created properly? Perhaps I should have used, instead of new future instance, I should have created a method here that says a new cancelled future. Then it would make sense. There is no reason to test more than what you're testing. You need to test just one thing. As at first, when you look at a test that you write, if you see that you're testing something, then you're doing something, then you're testing another something, and then you're using, and then you're asserting another thing, perhaps this should be 2 different use cases. Because if, for example, this test fails, then automatically I need to know that something is broken with a cancelled future. I don't want to know. I don't think that something is broken in the factory method. And to do that, I prepared like a small set of files that I wrote actually with Lena, which is not here at the moment, but we wrote during this week. I'll show a little bit what it does. It's not very complicated. I'm sorry for the non-Scala people here, but bear with me. Should be readable. Yes, it should. So I can show you the test, but it's very, very simple. Basically, everybody can see it, can read the code, or do I need to make it a little bit larger? Maybe a bit smaller. So there is 2 files here. There is the cache policy manager, and there is the cache policy annotation extractor. And what we wrote is a developer can add an annotation that mention what the cache policy is. So once it defines the cache policy, we extract the annotation, and we know which HTTP headers to put on the request. It's a very simple piece of code. If I'll go like really, really quick on it, there is the cache policy manager, cache policy headers for. It receives the method, and from that method, it extracts the data that the user added, and then it checks if it's a a specific, well, I hid too much data here, but it's in the test, it's more obvious. But if it sets a specific age, then and the specific age is 0, it will throw an exception. If it set a specific age, then it will create a header called cache control with max age that the user added in the annotation. And if it didn't define anything, then we automatically returned no cache policy. And that's it. That's the whole code. Anybody didn't get it, or I need some more explanation? Yeah, it's pretty simple. But I'm sorry?
What is the method type? What does it mean? It is a
Method is reflection. It's kind
reflection,
of
okay.
Yeah, the reflection, the
thanks.
description of the method itself. So this code is something that we will refactor the tests for it, but it's important to understand at least what the code does. And let's continue a little bit. So the first part in the test is the init of the context. You're creating some sort of environment for the test itself. Usually it's creating the sum of the objects and creating their collaborators. So in this section, usually in all languages, there are like two constructs. There is before all and before. Before all means run something once before all of the tests. And before there is something that happens before each test case is being run. Now this part you can do a lot of errors with it because if, for example, all of your tests needs to log into the system. So if you need to log into your system in all of your tests, then it's kind of you feel like, okay, I don't want to see it in every given part of each test that I need to log into the system. I will bury it before. I will just tell it, okay, so assume this is part of the environment. And in some cases, it might be correct, but pay attention. But if you look at a specific test and you think that the data that you're mentioning at the beginning is not important for the test, then you should put it in the before. But notice that someone that reads the test won't see that condition later on. You are hiding it. So I think basically that anything that comes in the before, when it comes to unit test, it's only the creation of the objects. It's not actually defining some of the behavior in it. And if you want to do something like that, I can think of an example. Like I said, if I have a test that does an integration with the system, like a build, like a whole, brings the server to check an API and see that. For example, in this case, login would probably be, it won't be significant for each test. It's just going to confuse anybody who reads it. But if it's a unit test, and in the unit test, one of the components does log in, and I'm hiding it in a before action, then someone who reads it wouldn't understand what the hell am I doing here. Makes sense a little bit? Because I see a little bit. So we'll see some more live coding, then I think it would be more obvious. And in our test, by the way, I have two tests here. This is the first test. This is the part where I'm creating the environment for the test. So I'm defining just a few random stuff that's being needed later, but basically the creation itself, this is everything I'm creating. In before all, for example, in my integration test, where I bring the system, in before all, I'm starting the server, I'm hooking up all the other components in the system, but I don't do more than that. So in each context, it should be very, very simple. It's this part. Creating a mock which is the extractor, and then creating the cache policy manager. That's it. Nothing else. After we created the init, there is the test description. And the test description is very, very important because when you write a test description, someone reads it. So use like natural language and describe what you're testing. It's very important that you describe what you're testing because later on someone might read it and try to understand what you're testing. Another thing is to use neutral language. Neutral language means usually English. I know that in some, it's when you're writing a system and other people in other countries will read it on later on, then usually English is the most common denominator. It's like, I was in a system where we wrote all of the variables and everything in Hebrew/English. It's like, and it's okay as long as every developer in the future will be Hebrew speaking. But if I would try to give that system to you or to anybody else in the world, they will probably look at me and think I'm insane because they won't understand any of the variables or any of the things. Another thing is when you write a good description at the beginning, it allows you to focus on what you're testing. If you just rush into writing the test and writing the code, then sometimes you find yourself writing a test for something that maybe you don't need to test. And the last part is this part does not compile. And if it doesn't compile, then in the future, when someone will add another behavior, you can expect him not to change it because there is nothing that will block him from not changing it. So if you have a component that extracts annotation and also does something else, and someone will add the something else later on, but probably will forget to change the description. So this is why it makes this part, even if you're writing the best description of your life and everybody who reads it know exactly what you're testing, be sure that someday someone will come and change something, and this part is already written, so it goes like, okay, that's fine. Let's look at the given part and try to refactor some of the code that I have. But let's talk about a few pointers. With the given part, we want to describe how we do stuff and not how, sorry. We want to describe what we're doing, what we're given, what is the environment that we define, and not just how we do that. Another thing is that we want to reduce the number of moving parts to the minimal number of moving parts there is. We don't want 5 different variables. We want just exactly the number of variables needed to test this code. So, and I'll show like an example very soon. This is basically what I said. Only the needed data. If there is, if you get 2 parameters but you're testing only one, try to make it just 1 parameter and not 2 of them. Because the more data you show, anybody who looks at the test later on, well, he'll think that's also important for the test. And this part is, I'm not sure I have like the perfect solution for this, but if you're using concrete values, if you're using, for example, the number 5, you need to test something and you add the number 5 or your email. In a month from now, when someone will look at the test, he doesn't know if 5 means anything. 5 can mean anything, and it can mean something like, let's say, for example, the code only fails when it's 5, and in another case, 5 is just a number that someone added and think, okay, I'll just write 5. So I think that it's smart not to use that, but use variables and have those variables mean something, describe what their meaning is. If it's an int, then just write some int or random int So someone who reads it knows automatically, no, it's not a 5, it's just a random number. So random numbers are...
I'll repeat the question for the sake of integrity. Do you suggest using mass random, or generating value?
Random numbers are, well, that's a delicate point, okay? Because I personally use random numbers for all of my tests. I think it detaches the data from your test, and there is also an option to use property-based testing that run each test with like 100 different random values. But the problem with random numbers is that you have to be very careful. If you add a random number to your test, then later on you might be tempted to write some logic in the test and duplicate the logic from your code. So if you write a specific logic in your test, then it might happen that the same bug that you have in your code will be on your test as well. So you need to use it carefully. Everybody's shutting down the microphone.
There is a point that tests should be, against random numbers, tests should be deterministic. So it means that you always should test with the same input.
Deterministic doesn't necessarily mean that it always have the same input. It just means that it's behaving the same way. So, but let's consider your example. You said it always gets a specific input. Let's say you're given it 5. Then the next one would be, I'll give it 6, 7, 8, 9, and 10. I better off writing, and like I said, you can use random or not use random, but if you're using 5 and 5 doesn't mean anything, then just add it to a variable. You can input 5 so it'll get the same input, but just mention that 5 is not important. Okay? I think usually the tests that I write use totally random numbers, and they always pass. I don't get flakiness between them.
Maybe in this case, it makes sense to have, if you have a part that is changed depending on the value of the input value, you should have at least 2 tests, maybe 2 same tests with 2 different values, instead of having only 1 test with a random value.
So you'll have 2 different test cases that test 5 and 6. Then you have... No, I'm sorry. Maybe I didn't understand.
Yeah, even better. We should test boundary conditions. If we check that our function return true if number is positive, we should check 0, 1, -1, and 1 million.
Okay.
Yeah?
So
it's not random. It's 4 different tests for different.
I totally agree, but instead of using -1, I would use a variable called negative number instead of 0. With 0, maybe I'll just add. I'll write the variable 0, or I'll mention it somehow. And 1 million, I will just randomize a random int, a positive int, and I will call it positive int. So. But again, randomness is a whole different topic that some people want to do it, some people don't want to do it. There isn't anything wrong with this approach or with another approach, but just be sure that if you're using randomness, you have to be a little bit more careful. Okay? So let's look at one of the. It's easier to explain stuff when you show code. There is this part where I'm checking, given a specific age annotation, return cache headers with time. So this specific case, this would be the given part. This is what I'm testing, and this is what I'm matching. So if we want to refactor this part, the first stage that I would probably do is, like you see, why do I want to, anybody like to think why I want to pack this method to something else? Why isn't it? Why shouldn't I keep it like this? the reason that I don't want to keep it like this is because this is how I'm not describing what I'm doing. I'm describing how I'm doing it. I'm saying that the cache extractor, when I'm asking the cache policy from it for this method, then it returns this data. So there is too much information for you to understand what I'm meaning to do. I want to do something else. I want to say, in this case, that the cache policy from returns this annotation data. So it would be easier for me to write a method that says, but we'll do it in stages. So if we'll go and try to write this in a different method, then I will write it. I will call it given something. I will pick a name for it. So the first stage would be just to take all the variables that I'm using and just add it to the just create a method that with all of that information. So I'll hide the first implementation. So there is method, and bear with me, but it's not going to be that long. Another thing is that I need it to return cache policy data. So I'm saying given annotation extractor with. So in order for me to write this, I will just use, I forgot the. So I have a given cache annotation with, I'm giving it this and method. So this is the code right now. I'll need to look at it, and this one now show me some. This is the first stage where I used to that I can refactor. Now it makes more sense. So I'm saying, well, I have an annotation extractor. It returns cache policy with max age and method. But I think I can go even a little bit more further with this because I want to describe what I'm doing. So I can say that the annotation extractor is with, so I can unpack this one and say with cache policy type and max age for method. So let's try now to see how it looks after I did some changes. In a second. And so the second part would be so now it makes more sense because I'm saying, wait, it has a type of specific age with max age for method. So I'm actually describing it a little bit better because now someone who reads it understands the contract is a little bit different. It doesn't need to know what the extractor returns. He knows just the details that he wants to know. He knows that the type is specific age. He knows that there is max age, and he knows it for this method. So when I'm calling this method, the extract policy headers, I'm seeing that in the end the data should be later on. It should be max age. We'll continue refactoring also the other parts, but the first part, this is the things that we aspire to have. And if we look at the first test, this is given no annotation returns default cache headers. So in this case, we're saying that if we're calling this method and it returns nothing, or like none is a construct that means there isn't anything in the data, then well, the lines are here too long. Then the headers that you should see is that there is no cache. So if we want to pack this part into another method that describe the contract with it, it would be, anybody wanna guess? Exactly. So I will do with no annotation for, and I'll give it the method. And it will look right now like this. This does it make more sense to you? Do you think it's more readable right now, or would you do something else? Too long. It's sure.
What about this method which you defined? Should I test him?
Which method?
Which you defined above. Yeah.
Oh no!
Should I? Why? Should I trust for this?
First of all, there is one thing that I forgot to mention earlier. When you refactor your test, you need to be extra careful, because usually the test works. It's green now, and if you break it while refactoring it, nothing will tell you. But if you write test for the test, then later on you'll have to write the test for the test of the test, and then you'll end up writing tests till infinity.
In this case, my method should be pretty simple to be sure that this method works correctly. No, that's because even I read this test after half year or after another guy, I must to trust him, no?
Yes, but to write tests for this is a little bit overdoing it. Like I said, when will you stop? There is no stop condition here. You will always have to test because you have to trust something, and this is the reason why you wanna refactor in very small steps, but also each of those given methods should be with very small amount of logic. You don't want to add too many things to it, because then it would be the test wouldn't be reasonable. But again, testing this for example in our code is what I wanna do with those methods. After we'll write everything. All those methods in here, we kind of creating a driver, and when you're running this code for your project, it's okay to leave it like this. But if you're exporting that driver to someone else to use, then yes, you write tests for it as well. But as long as for your internal use, I wouldn't. Writing more and more tests is not necessarily a good thing. You want to write as little test as you can, that test as much of the code that you have. You don't want to have a million tests that test just one thing, because if you'll have it, then you'll have to maintain 1,000 tests. And in this case, I wouldn't. There is a cost about adding tests. Okay, so the reason that we write tests is for them to help us. We don't want to be in the stage where we serve the tests and they don't serve us. So writing tests for the test, it's a black. I think it's a line that you shouldn't cross. Yes, you can respond, of course.
I'm trying to say that this method has some logic. Yes?
This method specifically only. Why before, when it was down here with the whole implementation? This is actually a mock that I'm defining a behavior for.
That's because it's abstraction.
When it's
inside my method, I can read it. If it's outside from piece where I read the code, it's abstraction. It must work, right? And if it must work, it should be. I must be sure that it works.
Do you have to see? Do you have to check that it works? It's kind of the chicken or the egg. The reason that I extracted this logic wasn't because I want to extract logic. I want to extract the logic because when you look at this test, that you know what you're testing, and what you're testing is not the behavior of the mock. You're testing your code, and to understand the abstraction, if you really in the end want to understand the abstraction, you can dig in the code and see what the code does. But at the first stage, the thing that I'm testing in this test case is not this part, and it's not this part. It's this part. This is specifically the part that I want to test, and I want you, when you look at this test, you know what you're testing and not the whole environment.
Actually, when you start writing tests, you usually don't use these abstractions at the beginning, and you create these abstractions at the refactoring phase. So usually, for me, for instance, I usually run straightforward the first two tests, for instance, straightforward. And then I start refactoring them, and then you can create such beautiful abstractions that are easy to read.
But you're doing two, and then you're refactoring the test while you're working on it. You mean this is the method that you're choosing?
First you write a test. You need to have something working, some working tests. So you just write straight away when it works. And you can write code and test it. Then you can, when you have at least two tests, then you can think of some kind of refactoring.
That's
progressive refactoring.
I would wait till the end to refactor it in order for me to know at least what I'm dealing with. Because like when I'm writing this code, my head is not in the test itself. It's more in the code right now. I want to implement the feature, so I don't want to break the cycle of exploring and getting more and more production code by trying to refactor all the time. And doing refactoring too early might make you create unneeded abstractions. From two usages, you cannot understand the whole picture. But I guess that everybody works like he wants. So this is, and the third use case, by the way, is something that if it returns a specific age with -1, then it will throw an illegal argument exception. If I would want to pack, like, this is an example of I can use this method the same way, but in this case, the specific age is a little bit less important. And when I read this test, I want it to be all about this parameter, the max age. For example, I used here a -1. So I want to make sure that if someone reads that test, he understands that using a negative number or for a max value is the illegal exception. So the thing I can emphasize here is I can tell it that this one is well, I'll have to define it in the context first. How is the Scala? Is it too hard for people here, or language is a language?
There are a lot of long words.
Specific.
And so this one allows me this part, and I always give an extra space, allows me to define more explicitly that max age with negative int will cause an illegal exception. Okay, and let's continue. Okay, the when part. The test that we're testing something, and we want to run it. The only rule that I have for it is just don't hide it. You're testing a specific behavior. You don't want to bury it inside something else. If you're looking at the code that you're testing, the thing that you are testing needs to be totally visible. It's not a good thing to hide the data, the API that you're testing, and you should show it off as much as you can. Because someone, for example, the test case that I showed before called log event with no parameters, so it hid the log event that we're testing, and this is hard for someone who looks at it from the outside to understand that this is the operation that you're testing. And there is the then part. The then part is the one that is the part where you match the expectation of what you're testing. And to do that, in this part, first of all, don't add any new data. The data that you're verifying against needs to appear in the previous steps, the given or the when. Do not add, like, for example, this is also from the example that I showed you. It checked that the BI events has the value foo and bar, but it never defined where the foo and the bar came from. So when someone checks and try to understand that expectation, he doesn't know where the data come from. So in this stage, you don't want to add any new variables to the test. This is the part where you match anything that you defined in the previous parts that you defined, in the given or in the when. Another thing is, and I'll show some example on it, is don't assert, match. In JavaScript there are matcher libraries, and the difference between asserting and matching is that asserting, you will say that a specific, if for example you have a person, then a person has an age and a name. So you'll do a person.age equals something, person.age equals something else. But this is asserting that each object has a property. When you're using a matcher, you can pack a few assertion into the same method. And if you have a specific, if you have more and more detail, more and more assertion, you can give them a common denominator and explain what they do. Another thing is check what happens if your test fails. Because if someone actually later on breaks something and your test fails with the weirdest message, then it doesn't help him. If you change the number and max age needs to be a positive number, then you wanted the test to fail and say the test failed because the number is not negative, is not positive. Those error messages are the thing that will help later on people to to understand what you need to do, what they need to do. And the naming of those matchers, it needs to reflect the language that the test talks with. So if we look at the code examples that in this one, the matchers are checking if that there is certain headers in them, but we can pack them into a single matcher that will say, in this case, it will say that there is no cache. The explicit values that appears here doesn't, first of all, I didn't define them before in the test, but I also, it doesn't mean anything to someone who reads this test. Someone who reads this test know that it extracts cache policy headers. So what we want to say, this part tells us how we test it. We test that those two headers exist. So this is how we know that this is what we know. And if we'll rewrite this matcher now, if we'll write, if we'll write something in the area of must have no cache or no cache headers, and remove that piece of information, for anybody who reads this test, it would be much more obvious what we're testing. At writing explicit number like this, explicit headers like this, would make you understand, would just confuse any of the readers of this test. So, and in this case, I would write something that would have cache header with max age equal the max age that I gave it. So again, now when I have this matcher, I know what I'm testing. I don't care exactly what the headers are. I care that this is their meaning, and the meaning in this test is talking in the language that the object understands. It doesn't use explicit values. Any question about it?
But then it appears that the description of each test is basically it's repeating what's written in its body.
Well, that's a compliment, no? If the test is readable like the description, then I think we achieved something.
But why we should duplicate this sentence? Why we should duplicate it in string mode, in a language mode? Let's remove the description and leave just a code and be sure that everybody will read this code and understand. That's because it's exactly what I'm saying in string mode, no?
Yeah.
It's the same.
There is only one difference between the two. Do you know what the difference between those two?
It's a string, it's a code, no?
This one compiles, and this one doesn't compile.
But what I should read it twice.
And which is not compiles is evil, because people can forget to change it, and the compilable part is more stable, more reliable. So no descriptions, we don't need them.
And description, yes, description is not being validated. But another thing is, if you have, this is a very simple test case. So you can say, okay, it was okay before and people could understand it. But if for example, I would have 7 different cache policies that will return headers that means do not cache this request. Then I will have in each one of them the same code that checks that there is the cache control with no cache and there is prog with no cache. And if tomorrow I would want to change the no cache, I would like to change it, I don't know, something I want to add another. I want to add also expires equal -1. Then I have to go to each one of those tests and add that specific header and add it. So this screams at you that this is an implementation detail. And the implementation here is the names of the headers. You don't want to write it and duplicate it throughout the code. Okay? This is the part that I'm trying to emphasize here. In the end, when you look at the code and if it would be readable as the description on the top, then you did something right. You don't agree with that? Okay.
Sometimes description, so here description pretty close to what we read in the code, but sometimes description can differ. So you can expose some meaning, and code will be different, not so close like here. It's just one example.
Yeah, I think that in the end the code counts, not the description. I don't know. You wrote documentation for some system. Does this documentation was correct all the time, or did someone looked at it after a month and it's always incorrect? So this is the description part. The description, I personally wrote a documentation for our REST API with another guy in the company. We sat and we had like 7 or 10 different iterations, and we looked at the code and we looked at the text, and then we wrote it and we write it again and write it again until we looked at the text and we said, this is what we intended. This is what we wanted. This is the perfect text that describes this API. A month later, someone called me and says, I don't know how to use it. Please, let's read the documentation together and see what's written there. So we read the documentation and I looked at it and I said, it doesn't mean anything. And then I checked the change log and I see that nothing changed from last month. So description is a very, even sometimes if you look at it, it looks readable to you, but you're not the only one who touches the test. You're not the only one who reads it. And if you have a condition where you say, like I said, if you tell me that I can read the test and I don't even need to look at the description, I understand from the test what you're saying, then then I did okay. This is the end goal that I'm trying to get to. I'm trying to get to a stage where the code is basically the documentation of the feature. So let's go on like a few last conclusions of what we saw today. A test should always stand by itself. If you look at the test, look at just the code of it from the start and end and read it, that should be enough for you to understand what's the behavior that you're testing and what does this test means. Don't use anything you didn't define. If you have something in the scope that you're testing against, it has to appear in the test in the scope that you're watching. You're watching it. You see it have like in the first example. You see the word or some string. That string had to be defined in the parts before that, in the given or in the when. Describe what you do and not how you do it. For every line of code that you see, that you write, you have to think, what does it mean? Does it mean that it's the how I'm testing it, or it's what I'm testing, and what will always be better? Use natural and neutral language. Like I said, should be a language that every developer in the company understand, and in this case it's English, and it always helps to learn another language. And the important part is to reduce the number of moving parts in the test. You want to have the test as fewer variables and words possible for the given test case that you're testing. Like if we tested the max age on the test, I could remove that the type of the annotation is specific age. I could remove it, but if I would remove it, it would make the test unreadable because you're just thinking that the max age is important. So we need to reduce the number of variables appearing before you, but we don't want to reduce too much of them. And that's the end of this. I hope it was easy. Any questions? And any more questions or sure.
Do you always extract all these first statements, given statements, yes, and all matchers?
Yes.
Always.
Always. I'm doing it first of all because when you look at the test case, it's first of all it's very it makes the structure even more understandable. So you know that the expectation you're using matchers to describe them, and you know that all of the context where you define the environment is the beginning, and the only thing it makes perfect sense when you look at the test and you understand what happens. And by the way, the given method that you extract later on, if you're writing the tests before the code, it allows you to understand what the contract would be against the other component that you're testing. Like, for example, if the cache extractor returns none in the default case, but later on you want to add a specific case that you call a default, then later on you won't change the test. You will change the contract itself inside of the draw. All of the pack of methods that you add in the given part, it allows you to understand the meaning of what you expect the other component to do. It forces you to realize that what each value should be, but it not always restricts you to the value itself that returns. It tells you what it means. So if you want to say that the default case is none, it's easier for you to do it after you wrote this method. But to answer your question, yes, I do it every time.
Okay. Thank you. And do you put all these helper methods in the same file?
No.
No?
I extract it to a different class, and then I put it in someplace else. Because in some cases I will, but usually I want to test if I can show you like a different code that I wrote, which is where is it? Usually those things they're sitting in a different file in a different area where I call it I put it in a package called drivers, and it has a lot of the things together. But when you open the test would probably would look something like this. You'll have the given, you'll have something that you do, and you'll have the matching at the end. But this is actually a code a test of mine from production. It's not an example. So everything is extracted, and later on what I usually do is that I pack them together according to their meaning. So, and I know naming is a problem. It can be better, but it always can be better. But this way I'm packing all of the related code to that specific component into a single file, and the file doesn't need to appear here, because all you need to know is that you have a given logged in user, and this is the logged in user. You don't need to know how to implement it in order to understand the behavior that you're testing.
Question about previous discussion about code duplicates inside methods. Correct me if I'm wrong, but my main code, which I actually going to test, should describe what I want to implement, not how.
The code itself also. Yeah, this is a basic refactoring mantra.
So in this case, if I understand correctly, my code should be matched with the test, except some special words like a must or return. Yeah?
No.
Why? If my main code
it's a good question. But listen, in production code, you describe what you do in the implementation. In the test code, you describe what you're testing. It's two different things, so it cannot be equal ever. But another thing that I forgot, I think, to mention is if you share, try not to share code between tests and production code. For example, if you have a constant that says that cache control headers are this and that, and you write the same, and you're using a constant that you use in production, in your development code, in your production code, then if someone just changes that constant, then it would change it in the test, and the test would pass. So in this case, you would probably, it would be smart to pay attention to those points and perhaps even duplicate the constant itself. I had a case where the constant was so important, they actually added a specific test that tests that constant that it has a specific value.
Yep. So first of all, thanks for the presentation. It was cool. So my question is, maybe you can recommend some, I don't know, test frameworks for Java World, from Java World.
For Java? Actually, we're working so much with Scala that it's hard for me to really give you a good recommendation. I know that well, there is JUnit, and there is also, to write matchers, there is Hamcrest, which is, from what I used it's the best that I know about in the Java world, but specs in Scala is like 10 different levels above it. But if you're working purely in Java, and you don't want to move to Scala, then I would guess that would be my choices. But again, all of the things that I said might be a little bit more difficult to implement using Hamcrest, for example, but it's totally well. You can implement them in the same way. You can make the code as readable as possible, like in Java, because in Scala you're allowed to save a lot of the boilerplate that you use. For example, in Mockito or in matchers, you need to run in Java assert that, have the value, and then the matcher. I'll give a short example. Like for example, the part that checks that the code throws an annotation in the first example that I showed, this one actually expects that this method will throw an exception. This is how it's written in Scala, and in specs too. So I don't need to do the try and the catch and do the failure. So you have the readability and the issues that comes from the language that you use, but you can always try to aspire to do it, like I said, to as much less letters and data that disturbs you. Any more questions?
There is a common phrase, maybe you've heard, that sometimes it's better to see once than to read about this 1,000 times. And there are some cases when your production code involves a lot of graphic-related stuff, some positioning, some dislocation, and it's maybe sometimes again better to show If you are writing some code that will recognize some patterns or shapes, for example, kind of table, and cross, and so on. Yeah, so it can involve some, the description of what you are trying to test. Sometimes it's easy to tell what you are trying to test, and sometimes it's very tricky to describe all this positioning, all this state, and either your description will be very, very long, and or I don't know, it will be lacking some details, and
description, like I said,
and
description.
when description is quite long, to describe some stuff which may be very simple if you just take a glance at it in real life. Yeah. Sometimes it's hard to read the test because it's really hard to describe some stuff. What would you recommend? Thanks.
First of all, I think that if you cannot describe what you're testing, it's going to be very hard for you to implement it. And regarding, so there is no answer that I can answer about this, because in the test description, if you're testing something which is very focused, I think this is one of the first tips that I gave about description. If you cannot organize stuff in your mind to explain what you're going to test, it's going to be very difficult for you later on. So if you got to a stage where I think you think you have to write 5 different lines of description in order for you to describe what you're testing, then you're probably trying to test too much. And as for graphical and stuff like that, it's very. I know that it's. I know, client people are struggling with that specific part, and I'm aware of it, and everybody's aware of it. But I know that, in Wix, we do the good fight, and we try to make it as testable as possible. The only thing I can say as a backend developer is, if you find yourself writing tests that break and you need to touch them all the time in order for them to work, then sometimes there are things that are simply, apparently at the moment, are not testable. And if you have a set of tests like that test a specific location or a specific point, and that point doesn't compute, or you find yourself messing with the test so much, then you need to consider those tests if they actually worth anything. But as for the description, try to focus. Try to focus and try to test just one thing at once. Don't test 30 things, test one thing. And if it's a shape, then you'll have a test that it knows how to draw a line, and then another test that knows to draw another line, and then you have to create a test that knows that that it calls both of the things that create both of those lines. This is basically test-driven development. You start with a big problem and you try to break it into small and useful testing scenarios and test everything together. I hope I answered that.
A note for this question: sometimes it's useful to, for your expectation part, to create some kind of state extractor that transforms the state of what you are testing to some readable, maybe some ASCII graphics or something that you can see really at glance. And in this case, you can have a nice assertion, and if it fails, you will see also at glance. And in this case, you can see you can have a more general description that it should draw the shape. And then you see how the shape looks like.
First of all, yeah, I agree, but you should be careful. Should draw the shape would probably be too abstract. But for example, I think I mentioned this before, but if you have so much code that extracts, usually I would pack it in a nice matcher to make sure that I understand. But if, for example, you have code that extracts something and checks something, and you write it inside, if you write it here, then it's a good. What happened that someone that will read the test would perhaps mistake the part that you extract the thing to the thing that you're testing. So it's very good to extract the code into a matcher, in this case, that have a reasonable name, because when you read the test, you'll understand exactly what you're testing. Like in the Java example of the exception throwing, you might be, because it has too many lines and the logic is split in two different cases, then you might miss something. And when you write a single matcher, although this is a built-in matcher of the language, but of specs too, but even so, when you read it, you know, you understand what happens here, and this is in the end what the thing you inspired. But don't create matchers with generic names like should be a shape. Try to talk in the language of the test. If it's a shape, that means if the test is drawing, I don't know, cookie, then you should probably should be a cookie shape or something.
Yeah, I meant in description of the test, like it should draw a cookie, not in the matcher.
But you risk writing another implementation, which can be as troublesome as the original one.
Yeah, this is actually what we previously. If the description doesn't compile, but yes, in the end it needs to. You can actually. I have tests where I said, given this and that, when I do something, then that will throw an exception. It's possible to find a pattern which makes it more understandable. But yes, in a way, the description is a duplication of what happens in the test. But it's not being enforced, and this is the biggest problem. Because if someone tomorrow decide that it doesn't need to be the shape of a cookie, but need to be a shape of a banana, and so somebody will go and change the test, and you go like, okay, now it needs to be a banana, and probably forget to change the description. So when it comes down to it, the code always wins. So if you are responsible enough to update both of the things, good. It's great, but if you don't, at least make sure that the code is readable in a way that someone can understand it, even without reading the description.
Last point from me. You said that try to avoid using constants in tests, but actually I think for every constant or enum you should have separate test, and you should probably use enums and constants in your test because they simplify reading of.
I meant don't use concrete values, like don't use the there are cases where you need to use to write the concrete value. There are use cases like this, but in most cases, if you can avoid it, avoid it. For example, if you have a string parser that have like that splits the words according to spaces. So you'll write the string as a concrete value in the given or in the when part, and then you'll match that it has the same like tokens that's supposed to be in it. There is no real there's no real reason to try to extract it to someplace else. So every law that we have, there are reasons that sometimes we need to break it. So this is why at first I mentioned and I said there is some guidelines. And when you look, first of all, when you look at the test and when you write a test, try to, and by the way, this is the most difficult part you have as a software developer, and to look at your code and try to forget that you wrote it. And try to look at it and see if someone else understands it. And if in some cases when we write code like that, we're kind of magicians. We're hiding some of that information, but we're showing different part of it. The question is, do you know, as someone who writes a specific part of code, you know exactly what the details, or you think you need to think what are the details that needs to be exposed in the test, and what are the details that doesn't need to be exposed in the test, and finding them, it's not something that is easy. Sometimes it's very obvious, but again, maybe it's obvious to you because you wrote the code. You wrote the code, so you're biased, and you know, he says like, oh, okay, of course, it's obvious. He does this and that because, like, I do this and that because it's what needs to be done. Everybody can understand that. But when someone else looks at your code, he goes like, why the hell did he do that? So there is no like a single truth. There is no like something that I'll tell you. You can go this way, and if you go this way, then everything will be great. Writing clean code is a journey, and every time you try to do something, and I personally I wrote code that I looked at a few years ago. And when I wrote it, it looked perfect to me. It was amazing. It was the best piece of code that I wrote, because it was but when I look at it right now, I said, no, it's not. I should have do this. I should have do that. You should aspire to make it cleaner. And the best way is when someone else reads your code, ask for feedback and tell them, does it make sense to you? Do you understand what I'm doing? And from those feedbacks, in the end, after you'll try and fail again, in the end, perhaps you'll manage to make and do something that someone will look at the system and go and tell you, okay, that's understandable. Other than that, there is no promises in that.
Short question about through N method. Is it part of a library, or it's your own method?
Which one?
Through N.
No, this is specs2 built-in matchers. A matcher. I mentioned it, but yes, it's built in by the library.
Oh, it's a library method. Yeah.
Well, the specs2 is it's a testing framework that it comes with built-in matchers. But let's like in this case, throw an exception makes perfect sense. But if, for example, we look at the cache extractor, then there is also, this is a good example. I'm trying to extract, there is a method without annotation, and when I extract cache policy from that method, it returns none. And none is it's like optional in Java. It's like integer or whatever. It's a built-in feature in the language. So in here, I thought I would refactor a lot more live, but I didn't. I didn't get to this point. But for example, here I'm saying that it's none. It's a built-in matcher. And what I wanted to say, like, there are built-in matchers that allows you to define what the results should be. But what I'm saying here is not that the cache policy, that the value is none. I want to say that it doesn't have cache policy. So I would like I got into this because when you said it's a built-in matcher, it's very good to use built-in matchers. But built-in matchers they often not speak in the language of the test. And the test speaks in a different language. It speaks in the language that we write. We write a component that extracts something, that adds something, that deletes something. If we wanna express ourselves, then we wanna talk in the language of the test. So using built-in matchers, like throw exception, I wouldn't wrap them, for example, but I would wrap this in a different. I just renamed the method to another name. Any more questions? Okay, so thank you for showing up. And well, that's I have my email here, and my. If you have any questions or you want to contact me, feel free. Also,